On a project you may know, which is the EuroMillion lottery. When Portugal joined EuroMillion, so I work for Santa Casa, and also in Ministerio das Finanças. But that was many years ago. I have forgotten all Portuguese words. So let me introduce myself. My name is Álvaro Sánchez. I'm coming from Madrid. I'm a Java developer, currently working on Micronaut at Oracle Labs. Oracle Labs is a research and development organization of Oracle, and we're working on. My team is working on Micronaut. I'm a committer on the project, not a developer advocate. And as part of Oracle Labs, there are other projects. For example, GraalVM is one famous project. You have my Twitter username there, in case you want to reach out. And then these slides are already available on GitHub, so, Speaker Deck. So you can take them from there. In the meantime, I would like to know more about you. So, who's never heard about Micronaut before? Yes, okay, that's a good place. And who's used Micronaut before? Yeah, so you currently use it? Just try it, okay. Now, who's using Spring Boot? Yeah, you can leave the room, please. No, I'm kidding. But I'll tell you a true story. I told you that I've been working on Micronaut since the beginning, 2017. So we started the framework several years ago. And originally, the framework wasn't named Micronaut, it was named Particle. But we couldn't choose Particle because domain wasn't available, blah, 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 so we had to choose a new name. And then we ran a poll internally across the team to choose a new name, and I proposed something which they didn't like. I think it was brilliant, but they didn't like it. So my proposal was to name the framework Summer, because summer is better than spring. And this is a joke. Okay, so I will tell you, obrigado. I will tell you about Micronaut and GraalVM. So there's 3 ideas that I would like you to get out of this session. The first one is Micronaut is a modern Java framework. It has not been designed 20 years ago, like your most popular Java framework in the market. But we started recently thinking of the type of applications that we create today. We no longer create like monolithic Word files, right, or ER files or whatever. So today is microservices, is REST APIs, is serverless functions, message-driven applications, etc. And we focus on that. So it's like a smaller pieces of work that we create today. The second idea is a general purpose framework. You can use it for anything you want. People typically use it for REST APIs. But you can create command line applications, serverless functions that can run on AWS Lambda, like a Kafka producer or consumer that hasn't a REST API at all, you name it. And the third idea is it is highly optimized. Performance is one, we're really obsessed with performance. We really want to be like the most performant framework, and we're like basically achieving this goal. So it is optimized in a way that the startup time is much lower than other frameworks, and the memory consumption is as well slower. And how do we do that? we leverage a technique called ahead-of-time compilation. So basically, all the things that we need to do in the framework, we do them at compile time. So going back to the Spring example, so when you have like a add service in a class, or for example, add auto-wired in a controller to inject a dependency, Spring essentially will do many things at runtime to make that work, including traversing all the source code, traversing all your dependencies, all your jar files, or all your classes, members, everything. It will scan everything. When it finds an annotation, it will create a runtime proxy. It may dynamically load classes. It will use reflection. Reflection is slow. So we've eliminated all of that. There's nothing of that at runtime, because we process all the annotations during compilation time. Like I said, this is a general purpose framework. There are many things, like the most important technologies are supported. So we've got you covered. In terms of history, we are at version 4 or 4.1. So we strive to release like a major release every 1.5 years, more or less. And we strictly follow semantic versioning. So you can, so patch upgrades are brainless. You just change the version, it all works. Minor upgrades are backwards compatible. And we only break changes during major versions. Quick overview of all the features we have in the framework. So, well, dependency injection is obviously the core of the framework. So, you typically use with Micronaut JSR 330 annotations like at inject, at singleton, etc. But you can even use Spring annotations in your source code. And the way this works is because during compilation we are able to map from any annotation to any other annotation, right? So we allow you to use other annotations if you don't like the Micronaut ones, right? So, for example, for injection, you have the JSR 330 annotations. We don't have our own, so it's the standard annotations. But you can use the Spring ones or even the CDI ones as well. For controllers, we have like a run annotations, but you can use a Spring MVC annotations, so JAX-RS. In Micronaut Data, you can use Micronaut Data annotations, or you can use the APA annotations, etc. So you get the idea. We're separating like the actual annotation that you have in the source code with what happens when we process that. We will process them the same way. In terms of configuration, we have like all major formats supported: configuration classes, type-safe configuration, configuration validation. So the typical features that you would expect. We have a built-in validation engine framework or API. It is an alternative to Beam Validation API, but Beam Validation API, it is highly based on reflection, so not everything of the spec is implemented. But you can plug Hibernate Validator and it'll work, right? It'll be slower, but it'll work. There is also like an AOP, so if you're doing like advanced features, you can use AOP. We use it extensively internally in the framework. But again, the way this AOP is implemented is different. So this is compile time, reflections free. Nothing happens at runtime. This is like a hello world. Or an HTTP server. So as you can see, Micronaut is using an annotation programming model. And it's an annotation programming model very similar to the Spring one. And this is on purpose because we don't want to reinvent the wheel, and we want the learning curve to be as slow as possible. So Spring users should feel at home very quickly with Micronaut. But we have like more goodies that are coming by default. Like, for example, a declarative HTTP client. For example, with Spring, you will need Spring Cloud Thing to have something similar. But again, the Micronaut implementation, like the Micronaut declarative HTTP client, is compile time. You declare an interface, and we implement the interface at compile time. It works. For message-driven applications, we have support for the major technologies. Same for data. For data, we use the repository pattern in Micronaut Data. This is similar to the repository pattern that Spring Data uses. But there are like more goodies, more improvements. Like, for example, well, this Scratch repository is the typical one that gives you like save, find by ID, etc., update, delete, like all the CRUD operations. You can define methods like this, and based on the method name, we will figure out what is the query that needs to be done. And you can even do like projections if you wanted to. The other good thing is that if you were to have a typo in either the method name or the parameter, it will not compile. So we type checked all of that during compilation, right? So this is supposing this user class has a name attribute, right? Otherwise, it wouldn't compile. And if you need to go deeper and have more control over the queries, you can go as low as you want. So you can go as, like, if you were using like Micronaut Data JPA, you could use HQL, or in this case, SQL. In terms of security, everything is more or less supported. So again, you can use the typical @secured annotations. You can inject principals in your controllers. There are built-in login, logout controllers, support for Auth 2, JWT, and all major authentication providers. Whoops. And there's more. Distributed tracing, serverless discovery, distributed configuration, monitoring, API development, very nice integration with test containers that you will see later, cache abstraction, email support, error handling, etc. So how do you get started? There is a website, launch.micronaut.io. You select the features that you want, and we will generate a skeleton application. Or you can use a CLI. If you're more into the terminal, you can download the CLI and create the application. There is an IntelliJ IDEA Ultimate Wizard and a Visual Studio Code extension. These are like different front ends for the same backend of creating a skeleton application, so they have the same options. Some notes about what we introduced in Micronaut 4 that was released this summer. So we've bumped the minimal version to Java 17. Who's not on Java 17 already on production? I'm gonna film. Who's not? Yes. Okay. So who's not on Java 11? So Java 8 or what? 11. Okay. Yeah. Yeah, you should migrate at some point. So for those unable to use Java 17, you can use Micronaut 3. Micronaut 3 is going to be supported for many years. And it'll work, but if you want to use like the new features of the framework, you need to use Java 17. All major Java frameworks are doing this push, so you will find the same approach in other frameworks. So yeah, using the latest Java version, well, you get like the performance improvement that comes for free with newer JDK releases. We're internally able to use the new language construct, so the code base is easier for us. And we are also allowed to support new elements, like for example, built-up threads. So if you're using built-up threads enable JDK, 17 with preview or 21. By default, the native loop will run on virtual threads. There are many improvements regarding GraalVM. Micronaut Data 4 is supporting latest Hibernate version, Hibernate 6, Hibernate Reactive. In general, the idea of this new release is to make the core of the framework smaller, much faster. So we've written the HTTP client and server library, and that's improved the performance by 40%. We've made some modules optional, so you will have to include them. Like for example, YAML. YAML is no optional. By default, we will use our properties. And there are like a few other small additions. One of the noticeable new features is expression language. So if you know Spring expression language, Spring Spell, this is similar, but again, it is checked at compile time. So this JC variable is referring to this JC parameter in the method. And if you were to make a typo in either of the places, it will not compile. Yep. And this allows you to, for example, use advanced conditions on Micronaut security if you were to do that. Another addition is beam mappers. I don't know if you are aware of MapStruct. Do you know that? Yeah. So MapStruct and there's other alternatives are like libraries that will help you to do mapping from a DTO to an entity, forth and back, because normally you should not render your entities directly to the client. So there will be like a DTO where you have like a projection of the attributes that you want to expose. And there are frameworks existing to help you with this conversion. Micronaut 4.1 is including one by default. So you simply produce, in this case, is a DTO is the result, and the input is the entity, and we essentially do the conversion. And you can specify custom mappings, like for example, the price in the DTO is doing like a calculation, and this is using the expression language we saw before. And all of this is type checked at compile time. Expression language is secure because essentially expressions are evaluated at compile time, so no remote execution or JShell exploits in this case. And Micronaut 4 also includes a development UI to see what's going on your application, to see the properties, beans loaded, change like the login levels of different packages while the application is running, etc. Meant for development. I want to mention as well Graal Cloud Native. So who knows GraalVM, or no, it exists? Yeah, a few people. So GraalVM was like the first project that used the Graal brand, but now the Graal brand is being expanded into three or more different projects. Now we have three. One is GraalVM itself, another one is GraalOS, which is a serverless platform, and the third one is Graal Cloud Native, or GCN. So GCN is essentially a downstream distribution of Micronaut built by Oracle and in Oracle servers. And the reason why this is important is because it provides the security requirements that some large organizations have that are unable to to basically use anything that is coming from public repositories like Maven Central. So there is like a security check on dependencies, SBOM, etc. And yeah, it has like it's essentially like Micronaut open source, but it's a downstream distribution, and you can get support from Oracle as well if you want. So graal.cloud is the website for the 3 sub-projects that I mentioned, in case you want to check it out. And finally, a note about GraalVM. So GraalVM became famous for one component, but let me tell you that GraalVM is an open JDK distribution. I personally use it locally as my JDK for all things Java, so you can use it too. And most of the applications will run faster just by using GraalVM on Git mode, like Java, JavaC, you have all the commands. So there's the 2 options that you have with GraalVM JDK. One is using as any other open JDK distribution, or you can use the native image component and produce a native executable of your Java application. Has anyone used GraalVM? Yeah, it's for experimenting, or are you using actually in production? In production? Yeah, that's great. I want to talk to you later to know this use case. So why is a native executable important? And the answer is because, well, there are like 4 benefits. Start fast is like a fraction of the time. You will see that later. So Micronaut Hello World is 250 milliseconds in normal JIT. Could be 10 milliseconds in GraalVM. So 10 versus 250. Low resource usage. So memory consumption is again a fraction. So we're talking about 150, 120 megabytes versus 12, 15, 10, 8, all for Hello Worlds. One thing to be aware of Micronaut startup time and memory consumption is that unlike other frameworks where startup time and memory consumption grows linearly with your code base, so the more beans you have, it will increase proportionally without any limit, right? With Micronaut, this doesn't happen. So there is like a footprint, which is the minimum you get. Obviously, if you keep adding like third-party libraries and other things that will do stuff at runtime, it obviously increase the startup time and the memory consumption. But for the framework itself, it's stable, so it doesn't add any overhead. Another benefit is it will minimize vulnerability, because one of the way a native image, a native executable is produced is essentially by removing unreachable code that you have in your dependencies. You may have like a, in a fat jar, you may have like lots of dependencies, but not every single class, not every single method, well actually class. Not every single class might be used from those dependencies. So only the classes that are used will be put inside the native executable. So therefore, the surface attack of your application is smaller. And then compact packaging, because it's like a single binary, you can distribute it and run it. Don't need anything else. Well, you need like libc and blah blah blah, but that's all about it. So GraalVM is supported on all major Java frameworks. So Spring supports GraalVM, Quarkus supports GraalVM, Helidon supports GraalVM, and Micronaut supports GraalVM. But the combination of Micronaut and GraalVM is unique. You can see the numbers, and there is like an enterprise. It's called Oracle GraalVM. Oracle GraalVM is like the enterprise distribution of GraalVM, which is even faster than this. So why the combination of Micronaut and GraalVM is unique? Because first of all, we're like we're sibling teams inside Oracle Labs. So we collaborate very tightly between each other. Also because Micronaut is ready for GraalVM since day one. For those using Spring Boot, you may remember the story about Spring Native and how long it took them to actually make it work. It was like 3 years, something like that. And the reason why it was like that is because with GraalVM, things like, for example, reflection. So GraalVM can support reflection, of course, but you need to tell it in advance which reflection usage are you gonna do, right? Or, for example, dynamically loading classes. It's another thing that needs to be configured. So there is a amount of metadata that you need to provide for those things that are, let's say, not GraalVM compatible without configuration, right? But since Micronaut doesn't do any of that, there's no metadata required for any of the Micronaut code. I must say at this point that I need to appreciate VMware's and the Spring collaboration, because we're collaborating on something called the GraalVM reachability metadata. So for third-party libraries like Netty, Hibernate, I mean, there are many libraries supported. We have a single repository of this metadata, which is a collaboration between Oracle and VMware. So the collaboration with them is working really well. And the third reason is the tooling we provide. So we provide tooling for Visual Studio Code. If you were using Graal Cloud Native, this distribution, it has a separate tooling that will allow you to do things like deploying the cloud and blah, blah, blah. This is a performance comparison between the 4 major Java frameworks. Startup time in milliseconds, so you can see Micronaut is the fastest. And this is in native image. So those 2 bars are Micronaut. So you can see the performance is impressive. So, and you can see also the difference between JIT mode and native mode. So this is JIT. 400. This sample application is not a hello world, so it's using security because it's done by Matt Frable, which is a developer advocate at Okta. So he's using Okta authentication, but still it's impressive. And there is a use case that I recommend you to use to read about, and is Disney Plus. So Disney Plus is using Micronaut and GraalVM on AWS Lambda, because Lambda is one of the typical book use cases of a native image, such that cold startup is much faster, right? And in the cloud, and especially in Lambda, less time is less money. It's literally less money. So they are saving money with GraalVM. And once they chose to use GraalVM, the natural selection was to use Micronaut because what I told you before. But there are other use cases, like for example, in Kubernetes, if you were to have horizontal pod auto scaling, and you want to scale to 0 or scale to any number of instances, it's going to be much better if your pods come online very quickly. So you don't have to wait much. So you can throw them away, and you can scale to 0 because you have the assurance that they will start up very quickly back when you need them. So that's another use case. And in general speaking, the performance of Micronaut is also beneficial during development. Obviously not GraalVM, because producing a native image during development is time-consuming. It takes about a minute to produce a native image. So it's not something that you're going to do constantly. Normally you generate the native image on CI, but you can work normally on JIT with Micronaut for development and then generate the native image later. So far, so good? Yeah? Blink if you... Thank you. Obrigado. Okay, so let's go to the demo. What I have here is, let me make this a bit bigger. I have here like a sample, like an empty Micronaut application that I generated from Micronaut launch. I'm including a couple of SQL files that I will use during the test, and that's about it. So let's create some code. The first thing I'm going to be creating is an entity. So let's call this team. This is going to be a record. And this guy is going to be entity. I'm using JPA annotations, but I'm not using JPA. I'm using Micronaut Data JDBC, which is a lighter weight version of Micronaut Data, which for those use cases, for the majority of the applications will just work. But if you need like full Hibernate support, you can use Micronaut Data JPA. But in this case, this is an example of what I told you before. So the annotations doesn't really constrain what you have at runtime. So in this case, I'm using JP annotations, but it doesn't necessarily have to be like that. Another annotation that I need, only for this demo, is @serdable. So in a like in a real-world application, you'll have a DTO, and then we'll have like demappers and everything. But that's a bit overkilling for a demo. So what I'm doing is I want this entity to be returned to the REST API, through the REST API, right? And that is what the @serdable annotation is. Another thing that Micronaut 4 is including by default is Micronaut serialization. Micronaut serialization is a replacement of Jackson. Do you know Jackson? Yeah, it's like the thing for JSON and XML marshalling and marshalling. It has a million of features, but it is huge. It's slow. It will make your fat jar more fat. Your application consume more memory to start slower. So we've built a replacement only for JSON. Obviously, if you need XML, you still need Jackson. Good thing is you can use Jackson annotations, and we are able to read them, but use Micronaut serialization under the covers. So you can see, like all these migration paths are really simple because we support most of the annotations. So this guy is gonna have long ID, string name, string state view. I have Copilot trying to suggest things. Normally it gets them right, but I've done this demo like, I don't know, 10 times. It still doesn't get them, so I think it needs to have more training data. And the generated value, and that's it. So the other thing I'm going to add is a repository. This is going to be an interface. We're going to call this team repository. And this is going to be a JDBC repository, and we need to specify the dialect, which is not, don't invent things. Right, and we're going to be extending CRUD repository, and we need to specify the, where is it? The entity class, entity type, and the primary key type. Okay? For this demo, with the default operations, I'm fine, so I don't need anything else. Next thing I'm going to be creating is the REST API. But for the REST API, I want to create a contract, and you will see why. So let's create a contract. I'm going to be calling this team API. It's like my REST API contract. And this is going to be an interface. We're going to be declaring like a constant with the path we're listening to. And then a couple of operations. One is, almost, copilot. And the other one is yes, and yes. But no, because I want to return in this case a wrapper, and I will explain this later. And that's it. And then let's implement this interface for the first time in the server. So this is going to be a team controller. Team controller, implements team API. Team API. So this is implement methods, and this is add controller, and we use the path that we declare on the interface. This guy, to do his job, will need the repository, so I'm gonna be declaring like this the repository, and then using constructor in JSON. No need to do auto-wired because or at inject in this case, because this is the only constructor for this class. So Micronaut will figure out that it needs to provide you an instance of the repository. And then the implementations are released, so this is final. You can return like POJOs or a collection of POJOs, and Micronaut will, in a blocking manner, will render that to you to JSON. Or you can wrap them in an HTTP response in case you want to change status code or headers or whatever you want. So what is this? This is repository, and then this is bound by ID, or else, no, we map it, yes, and yes. This time Copilot did his job correct. This should be it. And then what else do I need? Yes, let's try a test. I have a test here from the solution, but because in the solution I was using the video, but not here, so this is team replace all, and then this is an iterable, and then we need to cast this guy to a collection of what? And this is a collection of team. And then we cast this guy here, and then HTTP response, we import, and what's going on, team? Oh yeah, it's name. Team name. You can tell I'm a supporter of Real Madrid. So this is the other thing I wanted to show. A declarative client for myself. I want a declarative client to test my own controller. And this is as simple as extending the contract interface. That's all. Right? Since it's exposed on a slash path, or could be just this default slash, Micronaut will automatically make this client connected to the application instance that will be listening on a random port. So when you have a test with Micronaut test, this will essentially start the application on a random port and make this application a bean itself, so you can inject other beans from the application context. This client is going to be automatically connected to this random port for you. So far, so good? Yes? Okay, so we can test this with ambient test, and if I did everything correctly, it should work. But if not, I have the solution in a different folder, so don't worry. We're seeing many things here, and it failed, of course. Let me see why. The standard demo codes are not with me. I need to do a clean. Yeah. And fails again. Yes, I'm idiot, because this is Postgres. Okay, this is much better. So what happened here? You guys know test containers? Yes? So for those who don't know test containers is a library for using like database containers or any other testing container that you need for your application. So in this case, I want to use Postgres database, right? So with test containers, you have annotations and an API that you will use in your test to programmatically start a test container for your database. It will, for example, for Postgres, it will start Postgres and expose the Postgres port on a random port on your machine, and then you can grab that, build the JDBC URL for your application, blah, blah, blah. So that's how you manually integrate with test containers. Micronaut has something called test resources, and test resources is an abstraction over test containers in such a way that you don't even see it. So if you look at my test, I didn't use any test containers or anything like that. So why this works? Because if we look at the output, you can see test containers is starting a Postgres container. So why is doing that? The reason is because based on the dependencies that you have on your application, in this case I have the Postgres driver, and in this case, in my configuration, I don't have the JDBC URL. I have everything else, but not the JDBC URL. So this is enough for test resources to figure out, okay, so I need the URL, so I will start a database container for you. And we'll do that before the test, and we'll shut it down after the test. But the good news is that it's also available for local development. So if I were to run this application, like this, run, it will as well start the application with a database container. As simple as that, and I didn't have to do anything. But I'll tell you more, because while developing the test is often the case that you don't want to be starting and stopping containers all the time. So you can start. Whoops. Start test resources service. So in this case, I'm starting test resources service in the background, and then I can go to my test here, can run it from the IDE, and this should work as well. I'm going to run it again. Oh, then forgot what's going on. Oh yeah, makes sense. I'll cheat. Don't tell anyone. Actually, yeah, I should be like cleaning up the data afterwards. Run it again. Yep. So you can see this is 194 milliseconds to run the whole application. Not mocking, not unit test, not, it's the whole application on a random port. And you would tell me, you're cheating. That's impossible. But I've included in logback configuration to demonstrate that we're doing like an HTTP request to a random port. We're doing a JDBC query, and we're generating a response, all in 194 milliseconds. Now compare this with your favorite Java framework, and you tell me the difference. So this experience will completely change your mind about the pyramid of testing. You've heard about that. The pyramid of testing says that you need to write, the majority of tests have to be unit tests, and you need to use Mockito to mock this and that and whatever, and then fewer integration tests and very few functional tests. But think twice if that's still true with Micronaut. I want to give that experiment to you. And the final thing I want to show you, like the final show trick that will amaze you, is the native image. So let me see if I have anything here running. What do I have? It's because, yeah, so then stop test resources service. Let's see the stop containers. Come on. Test containers has something called a reuk, which is like something that will clean up containers for you. And now I will start. This is DB. No, DB. Not a stop. Start DB. Yeah. So we have Postgres running locally, and then I'm going to run the native image version of this application. So this is start native, start native, of course. Where am I? Because I did a clean. Don't worry, because then I will go to the solution. Solution, no, solution, and then start native. Let me do it again, because if you blink, you miss it. "43 milliseconds. And this is running the application, creating a connection pool, not inserting the data because the container that I started has the data already. But I think this is impressive, right? Now it's time for questions. In the meantime, that's a QR code for a small feedback form. So it's only like a rating 1 to 5 and an optional text. So I will really appreciate if you can give me feedback for my own benefit. So Do we have time for questions? Yes? Is there any question here? One question over there? How big is the binary? I think it's 80 something. So it's 79 megabytes. 75 megabytes.
What's the size of the jar? Just to do a comparison.
Yes, the size of the jar is well, this isn't the fat jar.
Yeah, of course.
But this is not near that.
Yeah.
So that's one downside of the native image.
But can we make it smaller? Let's say sacrifice some pieces to make it smaller.
Yes, there are some techniques to make GraalVM native executables smaller by using compression, but using compression will essentially increase the startup time because the image will have to be uncompressed. So you need to balance if you want to do that.
Okay, but that's fine. Thanks.
Any other question? One over there.
Hi. Do you have any object distribution with this technology? How do you interact with, for example, Rabbit? Or do you have messages built-in?
Yes.
Built-in, or you
built-in?
Okay, so you don't need Rabbit to do it.
Built-in. So for example, for Kafka Rabbit, we have like a Kafka client and annotations that will help you to create Kafka producers and consumers, or RabbitMQ producers and consumers.
So if you want to build streams between
for Kafka streams as well, the support, yeah.
Okay. Do you support transient and synchronous communications or persistent communications or? Persistent
communication, what's that?
Like message-oriented middleware built-in?
Can you give me like an example?
Yeah, for this message queues and something like that.
Message queues, there's support for JMS.
Okay.
If that's what you're looking for, so you can have like.
Okay. Do you have distributed references, or it's just about HTTP messages?
Yes.
Okay. Thank you.
Welcome.
Thank you. Hello. First of all, congratulations for your presentation and
Thank
for
you.
your product.
Obrigado.
You're welcome. But I was in the presentation you are always focusing in saying that in runtime or in compilation time the Micronaut verifies if a reflection is active or if is there any reflection, and you guys removed all reflection from your framework. Why you do that? What's the big advantage of that, and why do you prefer to not have reflection at all?
Because reflection is slow.
It's slow.
It is slow.
So only
it's slow, but it is slow in a magnitude that you don't even imagine. So it is that slow that even in Spring itself is, feeling pushed by the competition. It's removing some reflection usages and it's starting to do, for example, annotation indexing and some techniques to avoid the many things that they have to do at runtime. So reflection is slow, and because reflection is slow, what happens is that frameworks will have reflective caches. But then you will find Spring having a reflective cache, but also Hibernate will have their own reflective cache, because many parts of Hibernate are using reflection as well.
Yes, because of all of these applications use reflection.
It's slow. It's true that that's not like used to be in modern Java versions. So modern Java, in JDK, they are optimizing the performance of the reflection, but still you have the memory consumption. Because you wouldn't, you wouldn't use resolve all the properties of a class all the time, so you would cache that, and that's memory. That's unneeded. Okay. So the Micronaut annotation processing is far superior because we are able to work on, for example, type erasure at runtime, because we process your source code, and we have For example, if you're using generics, we have your class and your type argument, and we generate an enhanced annotation model which is better than the reflective annotation model.
Okay.
We have all the information.
Okay, thank you.
Welcome. Obrigado.
Hi. Hello. First
Hello.
of all, thank you for the presentation. We were focusing a lot about the runtime boot up and the speed that you get, but you guys are doing a lot of stuff at compile time. So we're gonna pay a price, right, at the compile time.
Compilation is a bit slower.
Yeah. My question is, it's gonna be two questions. So the first one is, how much are we gonna pay? And the second one is, if daily we have the developers working on this and they are paying a lot of compilation time, will not that affect the
productivity?
throughput? Yeah, the productivity. Yeah. So is there any way where we can actually have, like, at least at development time, something that makes developers go a bit faster but still work with Micronaut? So
let me answer your questions with another question. Did you notice the compilation at all?
No, not at all. But it was a test, so.
It's unnoticeable.
Okay.
Believe me, it is lower, yes, but it's unnoticeable.
Okay.
It's unnoticeable. And if you're really worried about that, if you have like a really huge code base, use Gradle. Because Gradle has incremental compilation. Incremental compilation is way faster and has like you can have a build cache, which is another advantage of Gradle. So, but it's unnoticeable.
Yeah. Okay. Thank you.
Obrigado.
Yeah.
Okay, thank you very much. You've been a fantastic audience. Obrigado.